This is going to be a level curve. So for a problem on a level curve, we are only depending on friction to keep us on the curve. So we're going to do a two-part problem here. One, we're going to say we know enough information to know what the centripetal force is, and we could figure out whether or not the force of friction on the surface is enough to keep us. And if it's not, how fast should we be moving in order to stay on the surface? So the first thing that we know is that the mass of the car is going to be 1,000 kilograms. And it's going to be driving at a speed of 50 kilometers per hour, which we're going to convert to 14 meters per second. And then the radius of this curve is 50 meters. So that right there is enough to figure out what the centripetal force is, because we only need mv squared over r, which is good. So we're going to do two situations. One where the road is dry, and that's going to be a coefficient of 0.6. And one where the road is icy, and that's going to be a coefficient of 0.25. So we'll do both and see what happens. So what we have to do is figure out what we need. So on this curve, like I said before, the centripetal force has to at least be equal to the force of friction. Now the force of friction could be bigger, which means it'll definitely stay on the road, but at the very least, these two things have to be equal to each other. Alright, so we're going to find centripetal force first. So Fc is going to equal mv squared over r. And the mass is 1,000, the velocity is 14, and the radius is 50. So when we go through all that, we're going to end up with a centripetal force of 3,900 newtons. So that means that the centripetal force of our dry and icy surface has to at least equal that, or we were not going to make the curve. So let's start with the dry, and we want to figure out what the force of friction is. Now force of friction, the basic formula, is coefficient times force normal. Now if we're on a level surface, that means that normal and gravity are the same size. So we can say that force of friction is equal to coefficient times force of gravity. And the force of gravity is just mass times gravity. So that means that for the dry surface, we're going to have 0.6 multiplied by 1,000, and then multiplied by 10 for gravity. So we are going to get a force of friction on this dry surface of 6,000 newtons. We only need 3,900. So that means on the dry surface, we are all good and we can make that turn on the dry surface. So now we have to try the wet surface or the icy surface. So same thing, we're going to find the force of friction, and that's going to be the same exact formula. It's going to be coefficient times mass times gravity, because again we're on the same level surface. So the only thing that changes is the size of the coefficient, so it's 0.25. That's going to be 1,000 times 10. So you multiply that, and we're only going to get 2,500 newtons. So as is, we won't make the turn based on this. We need to have at least 3,900, and we only have 2,500. So we're not going to be able to make it going at this speed. Now what we want to figure out then is if the road is icy, exactly how fast do we have to go in order to make it? Now at the previous part of the problem we said that centripetal has to at least be equal to the force of friction. So this is the relationship that we're going to use right now. So the centripetal force formula, mv squared over r, is going to be equal to the force of friction that we have right now, which is 2,500. And the mass is going to still stay 1,000, and the radius is still going to stay, it's 50, but we're going to be looking for the velocity. So we have 1,000 multiplied by v squared divided by 50, that's equal to 2,500. So you're going to multiply both sides by 50, divide by 1,000, and then take the square root. You're going to end up getting 11.18 meters per second. Now that might not seem like a big difference, but 1 meter is like 3.28 feet. So we're dropping down by 3 meters. So we're losing almost 10 feet per second, which is kind of a fast speed change. So even though it doesn't seem like it's a very big difference, it's pretty big. So on a surface that is more slippery, we need to go slower in order to make sure that we don't slip off. And again, that's because on the road, if you were looking at the curve, the car itself is being pulled in towards the center, by the force of friction. And it's not even so much that it's being pulled in, as that it's being kept there instead of being pulled outward by inertia. Because according to inertia, as you make that turn, the car just wants to go this way in a straight line off. And friction is what keeps it pulling inward the whole time. So this is on a level curve. So this is really all that there is to do on a level curve, is to find the force of friction and to know that it is equal to the centripetal force.